In this video, I'm going to show you how to put a piecewise function into Desmos and then use it to both graph and evaluate functions. So if I'm looking at this function g of x that I have right here, I see that there's three pieces. There's this top piece, there's this middle piece, and then there's this bottom piece. And you're going to want to put each piece into Desmos with a y equals in front of each equation, and then you're going to do curly brackets around where it wants to graph that piece. So I'm going to go to Desmos and I'm going to put in y is equal to absolute value negative 3x, and then I'm going to hit next to that. I'm going to find the curly brackets and I'm going to put whatever restricted domain that part was on. So I think this one was less than or equal to negative 3. Then I'm going to do y equals again, and then I'm going to do y equals again, and I'm going to go find those pieces. I think the middle one was 4. So from 4 and then x squared minus x. X squared minus x. And then again, I'm going to want to put those curly brackets to write where the x values for that piece were. So this one was negative 3 less than x, less than or equal to 0 maybe. And then this one was curly brackets. Let's make sure I'm getting this right. Greater than 0. Oops. X is greater than 0. All right, so if I zoom out, I can see all three pieces. I have a part of a absolute value, which looks linear, but it's just because you only see part of the absolute value. You see the constant line at 4, and then you see the portion of the parabola there. Sometimes if you are using this, if you click on the piece and kind of like travel along it with your cursor, you can get the point to show you that it's included. It'll be a dark dot like that at negative 3, 9. Whereas if I'm on this piece and I drag my cursor to the left, it shows me that it's an open dot, which is undefined there. And we would want to include that open dot if we were graphing it on paper. The reason it is open is because at negative 3 on the middle piece, x is greater than negative 3. You don't see that or equal to line at the bottom, which indicates an open circle. Whereas on the other side, it's a closed circle where x is equal to 0 because there's a line underneath the inequality symbol. So same thing here. Now, sometimes I can't get Desmos to show me that open circle, and it'll just leave it. So you got to be careful to know what the symbols mean when you're graphing it on paper. Now, another way you can do this, if you hit the settings wheel button in the table, let's say you wanted to know where x was 0. Well, in the bottom piece, even though there's a point at 0 and it should be an open circle, it says undefined. So that's your clue also that it should be an open circle if you were graphing it on paper. Or if you were evaluating this piecewise function at 0. So I'm going to hit the middle piece, hit the settings wheel table button, and I can see at 0 the answer is 4. And if I did settings wheel table and found 0 in the top one, it'd be undefined. So for every value that you're looking for, there should only be one piece that you can use to evaluate the piecewise function there. So if I was going to evaluate g of negative 5, that very first example underneath my g of x piecewise function, then I would go to the tables and I'm going to look for where I find negative 5. I just type it in. Negative 5 gives me 15. It's on that purple piece. But if I hit settings wheel table and type in negative 5 for these other two, settings wheel table again, it's going to say that at negative 5, those are both undefined. Because again, each value should only work for one piece of your piecewise function. And so Desmos can help you evaluate those functions by using that settings wheel table feature and then typing in whatever x value it is that you are looking for. Hope this helps.